All right, you already know how to configure OSPF, but there are some additional features you should consider. Find out what they are right here next on IT Pro TV.
You're watching IT Pro TV.
We are jumping into some different features on OSPF. You already know a little bit about the configuration, but there are some other things we should also pay attention to. And here to help us to sharpen our focus in on that, Anthony Sequeira. All right, Anthony, the configuration part we learned pretty much in the CCNA. We kind of know some of the show commands. We dived a little bit into it, but probably not as in-depth as we need to right here. So where do we begin?
Yeah, one of the interesting things about OSPF is the fact that there is a rich feature set. You think of EIGRP,
right?
And there's not the concept of areas. It's not hierarchical. There's no backbone with other areas. There's certainly no special areas like we have in OSPF. So one of the things I wanted to do in this episode, Ronnie, is spend some time in three main areas: summarization,
right?
Default route propagation, which I guess is summarization as well. And then the filtering component is something else that we want to look at. And that's trickier than you might guess. Mm-hmm. So let's begin in the area of summarization. So default information originate. This is where we are having OSPF propagate the ultimate summary, right? The default route.
Right.
And there's one caveat that I know you and I were discussing this morning. There's an optional, well, first of all, let me back up.
Yeah.
What we do is when we have an OSPF speaker that's like connected to an internet service provider, and that's where we're going to direct traffic destined for the non-interior of our organization, of our enterprise, it needs to advertise a default route. Super easy way to do that. You can go in router configuration mode, so router OSPF 1, for example, and then you issue the default information originate command. If you have a default route in place, if you have the default gateway set on that device, it will advertise that to all of the OSPF speakers. What a nice feature. There's a keyword you can tack on there, Ronnie, right, of always. Wow, use that with caution, because that means your router is always going to advertise itself as the default gateway to all the OSPF speakers, even if there isn't a true default route set. So you could create, if used improperly, a black hole situation where everyone's sending their, I don't know how to get their routes, paths to you. They're looking to you as the default gateway, and you might not truly have a default static route set up. So just be cautious with that always keyword.
All right, so with this particular command, so that we make sure that we get it set up correctly, is there, so if I have 5 routers inside of my IGP and I'm running OSPF, where would I normally run this? On all 5 routers, or would I run this? Okay.
That is a great point. So remember, the default information originate is truly on that typical edge router, right, that is going to get everyone to the internet, is what it's commonly used for.
All right, so what is this Area 20 range about? What would we take a look at?
So first of all, everyone, I don't like it when we have to cycle to another line there, but notice anytime we do that, anytime that the command won't fit all on one line, just notice what I do, I indent. So our command here, Ronnie, is area 20 range 172.16.00, and then our 16-bit mask. What we are doing when we do this is we are saying that area 20 has what we call component prefixes in it for 172.16 something,
right,
and we're summarizing that. A great example of this would be to summarize those into the backbone, for example. So we do this on an area border router, and we're saying, look, Mr. or Mrs. Backbone, we are going to advertise into you 172.16 instead of doing like 172.16.1, 172.16.2, 172.16.3. See how that works? So the area range command is a great technique, and I want you to know this one for sure, that you would do in an area border router in order to set up summarization exactly the way you want it. Remember, Ronnie, a point that we often miss is this helps your environment become more stable. Because if the 172.16.1 prefix has a problem, there doesn't have to be this update into the backbone.
Right.
The backbone is just unaffected because it's getting the summary of those prefixes.
Yeah, so Anthony, I think this also helps us to stress the idea of how it's important for us to design our IP addressing scheme correctly. Because if I get some that are weird, like I get 172.16.1, but then the next one is .17 and then 45, then this could still do it, right? According to what we have here.
Yes.
But sometimes, though, if we get like 192.168, all of a sudden we're
You're
done with it.
absolutely correct.
Okay.
In fact, Ronnie, this is near and dear to my heart because I'm teaching the NSLED,
Right.
the kind of design NP course. And one of the first videos that I created was how to design your IPv4 addressing.
Okay.
And one of the tenets is that you should design the addressing so it can be properly and easily summarized.
Great idea.
Yep. Well, let's move on.
All right.
Let's talk filtering. Now,
Right.
this gets, I'm just going to say it, this gets much trickier. There's many different ways to filter. So you've got a lot of tools in the tool belt, Ronnie. You need to make sure you grab the right tool. You don't want the straight screwdriver when it's a Phillips head screwdriver. And that's the last construction analogy I'll ever give because that's not my area. So, and speaking of areas,
Yep.
So the first one we see, I have to admit, if I knew this trick at some point in my life, I forgot it.
Okay.
I really did forget this trick. Watch this. We use that area range command again, Ronnie,
Okay.
but we actually use it in a really interesting way. We give a specific prefix and then we add the keyword not advertise.
All right.
Had you seen that one?
I have
before?
not seen this one
Yeah,
before.
this is like, it's almost in the category of like stupid router tricks, right?
Right.
But what a cool, easy way. So here, we don't want to advertise for whatever reason the 172.16.12, like into the backbone, for example, from area 12. So we just specify it and say not advertise.
Yeah.
And it will advertise everything else but that specific subnet.
Now, I'll tell you where I would get tripped up with this particular command is because when we normally configure network OSPFs, I always think of wildcard mask, but that's not a wildcard mask here, right?
That is not a wildcard mask. Yeah. And
So-
it's tempting to use the
Right.
wildcard mask in that command. So, and again, these are fun ones that you could practice with
Right.
if you really wanted to nail these down. If you're practicing with these, you're going above and beyond, I'll be honest with you, what's required for your exam. But hey, it's great to practice with them so that you could use them in production.
So this would be a good use. So for example, we did have an exam question. I know that we kind of aren't doing that, but if we did have one where it said you need to prevent this particular network from being advertised into OSPF.
Yeah.
Or, okay.
Into like the backbone.
To the backbone.
Then this would be an easy way to do it. And whenever you're presented with something like that, you want to use the easiest possible method. And boy, is that easy.
Yeah,
Notice we didn't have to create like an access list and then tie that in. It's just right there in one command. Hey, don't advertise this prefix. Like I said, if I had known about that one at some point in my life, I sure forgot it. The next one, I didn't show the complete config on because it would be, it's pretty straightforward. The my list right there is an access list. And this is called the distribute list approach. And what you're doing here is you are specifically attacking those external prefixes that might be coming into your OSPF domain. And you can go, I want to trim those. I want to only permit some and deny others. And you create a simple access list that says what prefixes that you want. And then you tie that into OSPF with what's called a distribute list. And now you can control the LSA type 5s. Remember those? Those external prefixes? You can filter those. This is the slide that I was familiar with from my, longtime studies of OSPF. What we're doing here is we're doing what's called a filter list, Ronnie.
Okay.
And what's cool about this is it uses the prefix list that we love so much in Border Gateway Protocol. So let's break this down line by line. IP prefix list, my list, sequence number 5, we want to deny 172.16.1/24. So notice we're being very specific with the prefix list and notice you get to use the / prefix notation.
Nice.
It's always nice. So forget about the old wildcard mask, which is so difficult to type in. We're saying deny 172.16.1, and then the next line permits absolutely everything else. So that's your override of the implicit deny all behavior. And that prefix list denies that prefix, and it's then very easy to tie into your OSPF configuration. Notice we do area 0, filter list. The prefix list is called my list, and we're doing that in the inbound direction. So you can see this is a very powerful feature built into OSPF to filter prefixes from entering a particular area. In this case, it is the backbone.
All right, so Anthony, in the center, our prefix list, where you actually have the wildcard mask or the entire default,
notation.
on the all zeros there, you have LE. Now, there's more than that option there for just LE, right?
Yes, if you haven't played with prefix lists in a while, you don't need to for the Encore exam, but please be familiar with prefix lists. When you get into more advanced Border Gateway Protocol, they're the thing. Like, we need prefix lists. As a matter of fact, I think they were pretty much invented for BGP's usage. So really look at them. They're super convenient compared to access lists when it is prefixes that you want to identify.
Yeah.
And you mentioned there's other options that's less than or equal to. There's greater than or equal to. There's all kinds of nice keywords we can use that indicate how long the subnet mask is that make them very convenient.
And this one, we're just saying it's all 32 bits, that it should actually permit anything.
That's right.
Okay.
Yep, that's right.
All right, so on this one, so we've talked about the idea of OSPF filtering and also the other component that we're actually just doing there, which I can't remember for the life of me, that we were just talking about.
Well, we did the default route, which is like the ultimate summary. And then we did more specific summarization, and then a bunch of ways to filter, Ronnie.
Yeah, so the ideas here, right, on these different OSPF features are really key and critical as you begin to move forward with OSPF. But as Anthony said, make sure you practice and look at these things and the output of them. It's easy to configure, but you need to go back and run those show commands, verify that they're actually doing what you expect them to do inside of the actual routing table itself once everything is done. So the idea of these filter lists that we actually have, everything else that we've been doing here, all that's going to be important, as well as the summarization. Well, that's enough for this particular episode then. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.